Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over the acid-base properties of ions and salts. And we're going to start with anions and go and talk about anions and their properties in the next few videos, and then we'll talk about cations. So let's get into this. So we saw before that HCO3 minus the bicarbonate ion is a base in water. So the HCO3 minus will react with water, and it's going to take a hydrogen from water and reform your carbonic acid, and you got your OH minus left over. So this is acting as a base, but your bicarbonate ion does not exist, does not exist by itself. It's not there by itself. It's usually in the form of a salt. So these anions exist together in a neutral compound, a salt or a ionic compound, and that's how they exist. So here is where it would probably be as a solid. So you have your sodium bicarbonate. Your sodium bicarbonate as a solid is then, when it put into water, will dissolve and then dissociate into your Na plus ion and your H3 CO3 ion, your bicarbonate ion. So here we're going to be talking about the acid-base properties of ions. Your sodium ion here is not going to ionize water, so that's not going to be neutral, and we'll see that in a moment or in a later video. So your sodium ion is going to be neutral in water, but here, as we saw, when the bicarbonate ion is put in water, it's going to ionize water, take a hydrogen or H plus from water, and reform your carbonic acid, and that's going to leave your OH minus. So in water, this salt here, or this ion here, this ion acts as a base, whereas the sodium ion is neutral. So how do we determine the basicity and the acidity of different ions? Are they neutral, or are they going to act as bases? So first, we're going to talk about anions, and anions are typically going to act as bases, or they're going to be neutral. Your cations are going to typically act as acids or neutral, and we'll talk about the cations in a later video. So anions, let's look at anions. Anions are typically either weak bases or neutral. And so here we see the anion here is acting as a weak base according to this equation here. So why is it? So we can understand that that these anions are typically conjugate bases of an acid, right? So whenever you have an acid, the anion of that acid is the conjugate base of that acid. So for example, here is the general or generic equation of an acid. So you have HA is your acid, and that's going to ionize in water, and that's going to give you your H plus and your anion. So you can see that the anion is the conjugate base of the acid. And remember, conjugate acid-base pair are those pairs of species that are associated with each other by the transfer of a proton. So the negative ion is the conjugate base of your acid. So a couple of examples, I have HCl is your acid. That's going to ionize in water with H plus and Cl minus. So Cl minus, this negative ion, is the conjugate base of your hydrochloric acid. And then here you have nitric acid. That's going to dissociate or ionize in water, and that's going to give you H plus and your nitrate ion. So the nitrate ion here is the conjugate base of this acid. So then these ions here can either be neutral or they can be weak bases depending on how strong the acids are. So what to keep in mind. So if you have an anion that is the conjugate base of a weak acid, then that itself will be a weak base. So the anion of a weak acid is a weak base. Okay. The anion that is the conjugate base of a strong acid is going to be pH neutral. So you got to remember that. So anion of a strong acid is going to be pH neutral. It's going to be neutral in water. Okay. Well, why is this? um, the other thing that I'll talk about that in a moment. The other thing to keep in mind is the weaker the acid, the stronger the conjugate base. The weaker the acid, the stronger the conjugate base. So why is this? Well, why does this have this sort of relationship with conjugate acids and bases? And so we talked about this before, but let's review here again. So when we have a weak acid like HF, right, why is it weak? Why is it strong? It has to do with the affinity of the anion to the H plus. So to your H plus ion, the more affinity your anion has to the H plus, the more it's going to hold on to it, and it's not going to let it go as easily in water. So if you have a strong acid like HCl, well, the chloride ion or the chlorine atom, the chloride ion here does not have a very strong affinity to H plus, right? So it's going to let go of that H plus readily, very easily in water, so much so that all of the HCl is going to ionize into H plus and Cl minus so that you don't have any HCl left in water, right? So that's how weak Cl minus has, that's how weak the affinity HCl minus has for H plus. So because of that, if I take Cl minus and throw it in water, the Cl minus is not going to ionize water. It's not going to take an H from water and form HCl and leave the OH minus there. It's just not going to do it. It doesn't have a very strong affinity for the hydrogen of water. So that's why it would be pH neutral. Okay. Now take a weak acid. So if we take a weak acid like HF, well, the fluoride ion, the fluorine there, does have a very strong affinity for H plus, right? So it's going to hold on to this H here. It's not going to let it go very easily in water. So very little of this is going to ionize in water to form the H3O plus. So as we've said with the equilibrium, right? So the equilibrium for the weak acid lies far to the left here. So it's far to the left on this side of the reactant side. So this is going to be the major product in water. There's going to be a little bit of this, but it's going to be mostly by far your HF in water. Okay? But with your strong acid, the equilibrium lies far to the right, so much so that you have all of this in water and none of this in water. And that has to do with the affinity of the anion to the hydrogen. The lower the affinity, the weaker the acid. I'm sorry, the stronger the acid. The higher the affinity for the H plus, the weaker the acid. It's not going to ionize as easily. So when we look at fluoride ion, right? Since fluoride ion has such a strong affinity for hydrogen, if I took fluoride ion and I threw it in to water, then the fluoride ion is going to seek out that H plus from the water. So then the fluoride ion will then seek out the H plus from the water, take the H plus from there to reform the HF, and then you'll have OH minus left over. So this reaction is going to be form a basic solution, and it's going to have a Kb value associated with it. The HF, this equation here, where that reacts with water, that's going to be a Ka. So the anion of the weak acid is also a weak base, and therefore is going to have a Kb or base ionization constant. So that is how we can understand why some of the anions from acid are going to act as bases and some are not going to act as bases but are going to be pH neutral. So I hope this helps. If you enjoyed this video, if you learned something from this video, if this is very made things clear for you. Thanks for hitting the like button, right? So hit that like button. Um, Make sure you subscribe to my channel. Hit that notification bell right up there, right there. And so that way you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think. If you have any questions, please ask. Thanks for joining me. Have a great day.